Welcome, welcome back to the Cave Science. We're going to do some mole mass conversions using the factor label method. These are pretty straightforward one-step conversions. So the first one we're going to look at, we want to know the mass of 3 moles of iron. Well, if you look on your periodic table, you'll find that iron has an atomic mass of 55.85. And that'll be 55.85 grams per mole. So what we have is 3 moles, and we want to know what the mass of that would be. So in the factor label method, you always start out with what you have. So we have 3 moles of iron. And I always like to put the first factor over 1 if there is no denominator. This gives me a good visual. There's different ways you can denote this. Back when I learned, I used a multiplication sign, and so then I have the next factor, and if I have moles of iron in the numerator here, moles of iron will have to go in the denominator on the second factor. So we know 1 mole of iron has a mass of 55.85 grams. So 55.85 grams of iron. The beauty of the factor label method is if you can cancel out the labels, it's really a good check to know if you're on the right track to solve your problem. So we've got moles of iron in the numerator, moles of iron in the denominator. We want mass or grams, and that's what we have left. So we know our setup is correct. So from here, we can go ahead and multiply the numerators, divide by the denominators. So this one's pretty straightforward. 3 times 55.85 is 167.55 grams of iron. And that is what we're looking for. We wanted the mass here. So this answer makes sense and would be correct there. For all these problems, I'm going to go to hundreds on the answers. You can do a lot of chemistry classes will go to the hundreds, but we're just going to stick, or to the thousands, but we're just going to stick to the hundreds here. So here we're looking a little bit different here. We want to know how many moles of carbon is 75 grams of carbon. Well, carbon has an atomic mass of 12.01 grams per mole. And again, you can get these values off your periodic table. So how many moles, this is what we're looking for, and this is what we have. So we can start with 75 grams of carbon. And I like to go over 1. A lot of times now you'll see in the factor label method, we'll start setting it up in this way, which is fine too. And I'll do this one using the vertical line here to separate the factors. Well, if I've got grams of carbon in the numerator, I need grams of carbon in the denominator. And we know there are 12.01 grams per mole. Again, that's going to be your factor. So we have 12.01 grams of carbon is 1 mole of carbon. Well, if we look at this, we can see our grams of carbon are gone. There's numerator here, denominator there. Here's what we're left with. This is what we're looking for. So we know this setup is correct also. At this point, multiply the numerators, divide by the denominators, and we should come out with something in moles of carbon. Well, if we go ahead and do the math on this, we end up with 6.24 moles of carbon. So again, really 2 same types of problems. One we're solving for grams, and the other one we're solving for moles. Let's do a couple more here, and we'll use a couple formulas on this. So we want to know how many moles of sodium fluoride and 80 grams of sodium fluoride. Well, from your periodic table, you can go ahead and calculate the mass of sodium fluoride. And if you look on your periodic table, you'll find sodium has a mass of 22.99. So we have sodium has a mass of 22.99, and fluorine a mass of 18.998, and we're going to call that 19. We'll call that 19. So then our mass of sodium fluoride is going to be 41.99 grams. 41.99 grams. And again, that's going to be per mole. Now we're looking at a compound here. So let's start with what we have. We have 80 grams of sodium fluoride. I like to put those over one. I'm going to use the multiplication sign. If you want to use the vertical lines like the problem above, that's fine also. Well, we have grams in the numerator, got to have grams in the denominator. Well, we know 1 mole of sodium fluoride has an atomic mass of 41.99 grams. 41.99 grams of sodium fluoride. I'll cover that over a little bit more. And if we're looking at this, we can see grams sodium fluoride numerator, denominator. We're left with what we're looking for, and we're looking for moles of sodium fluoride. Moles of sodium fluoride. And if we go ahead and do the math on this, we come out with 1.91 moles of sodium fluoride. Again, pretty straightforward. And the beauty of the factor label method, if that last label is what the label of your answer should be, you set the problem up right. And after that point, it's pretty much go ahead and do the mathematical calculations. And let's do one more here. What is the mass of 2 moles of carbon dioxide?
Well, we've seen before.
We know that carbon has a mass of 12.01 grams. And oxygen, we actually have 2 oxygens in this. And oxygen is 15.999, and we're just going to call it 16 and times 2, so that'll be 32. So that'll come out with a total of 44.01 grams per mole of our carbon dioxide. Well, let's go ahead and set this up. We've got 2 moles. 2 moles of CO2. And let's do the vertical line again here. Now we got moles in the numerator. We got to have moles down here. So we go 1 mole of CO2 is 44.01 grams per mole. And this cancels out. This cancels out. We're looking for mass, which is grams, and that's what we've got left. So we'll have grams. This should actually be CO2 here. So we got grams of CO2, multiply that, and it comes out to be 88.02. 88.02. Yeah, this should have been grams of CO2. My mistake there. And there's our answer for that one. So these are some simple problems, and we'll come back here in the next couple of videos doing some mass, volume, and other types of very simple conversions. So, till next time.